Welcome to my YouTube channel. Learn at ease. In this video I will discuss a topic in biochemistry. Biochemical properties of water. Part 1. Structure of water and ice. Let me begin by portraying importance of water. Water is a major chemical component of the Earth's surface. It is indispensable to life. Indeed, it is the only liquid that most organisms ever encounter. Life originated, evolved, and thrives in the seas. Organisms invaded and occupied terrestrial and aerial niches, but none gained true independence from water. Typically, organisms are constituted of 70 to 90% water. Indeed, normal metabolic activity can occur only when cells possess at least 65% H2O. This dependency of life on water is not a simple matter, but it can be grasped through a consideration of the unusual chemical and physical properties of H2O. Now let me show you some remarkable properties of water. 1. Unusual properties. As compared to hydrides of oxygen, which are 1. Ammonia, NH3. 2. Hydrogen fluoride, HF. 3. With the hydride of its nearest congener, sulfur, H2S. Water has a substantially 1. Higher boiling point, 2. Melting point, 3. Heat of vaporization, and 4. Surface tension. This is because 1. Intermolecular forces is high in H2O. 2. Internal cohesion is high in H2O. Other important facts of water. 1. Water has an unusually high dielectric constant. 2. Its maximum density is found in the liquid state but not in the solid state. 3. It has a negative volume of melting, that is, the solid form, ice, occupies more space than does the liquid form, water. It is truly remarkable that so many eccentric properties should occur together in a single substance. The key to its intermolecular attractions must lie in its atomic constitution. Now let me describe the structure of water. Structure of water is as shown in the image. 1. Water molecule is polar. 2. Structure of water is tetrahedral and it is sp3 hybridized. 3. Bond angle is 104.5 degrees and not traditional 109.5 degrees for sp3 hybridized molecule. Due to electron crowding of non-bonding orbitals of oxygen. 4. Oxygen nucleus attracts electrons more strongly than hydrogen nucleus, proton, so sharing of electrons is unequal. 5. So, each hydrogen bears partial positive charge, delta plus, and oxygen bears negative charge equal to 2 partial positive charges, 2 delta. Let me show you one of the most unique property of water. That is its ability to form hydrogen bonds. This image shows 2 tetrahedral-shaped water molecules forming hydrogen bond. In the image hydrogen bond is formed between 2 neighboring water molecules. Hydrogen bond is also called H-bond. Bond length of H-bond is 0.177 nanometers. Whereas the covalently bounded proton and oxygen has much smaller bond length. That is 0.0965 nanometers. The bond dissociation energy, that is the energy required to break a bond, is much lower for H-bond, 23 kJ per mole. As compared to covalently bonded hydrogen and oxygen of water molecule, that is 470 kJ per mole. Thus H-bond can be considered as a weak bond. The image shows several water molecules forming H-bonds with their neighboring water molecules. As the H-bonds are weak bond, they are readily been broken down. However, new H-bonds are reformed is shown in the image in the right. Thus this breaking and reforming of hydrogen bonds continues, and as this process continues, the symmetry of H-bonds amongst water molecules keeps changing and is never constant for water in liquid state. Some important facts of H-bonds are: 1. Lifespan of HO, hydrogen bond, is 1 to 20 picoseconds. Where 1 picoseconds equals 10 raised to minus 12 seconds. 2. On breaking of one hydrogen bond, another hydrogen bond is formed in 0.1 picoseconds. 3. Phrase for this phenomena is known as flickering clusters. 4. At any moment one molecule of water forms 3.4 hydrogen bonds in liquid state. Now let me show you some facts about solid form of water, that is, ice. Some properties of water changes in ice. Such properties are: 1. Density of ice is less than water in liquid state. 2. Ice has negative volume of melting. 3. Ice form hexagonal lattice by forming hydrogen bonds. The image shows that hexagonal lattice formed by H bonds with its neighboring water molecules. 4. Bond length of hydrogen bonds, HO, in ice is 0.274 nm, whereas, in liquid state the HO bond length is 0.177 nanometers. 5. 1. Molecule of water in ice forms 4 hydrogen bonds. 0.4 and 5 attributes decrease in density and negative volume of melting. References. If you are new to my channel, please subscribe below. Thank you for watching my video.